Good morning, sixth graders. Today we are going to continue exploring cylinders, and we're going to look a little bit more closely at surface area of cylinders. And there's this situation where a fruit tree juice company packages its most popular drink, cran apple juice, not my favorite, in cylindrical cans. Each can is 11 centimeters high and has a radius of 2.7 centimeters. I used to love getting orange pineapple juice in cans as a youth, your age. All right, so anyway, sales reports indicate a decline in the sales of fruit tree juice. At the same time, sales of juice made by a competitor, the Fruit Blast Company, are on the rise. Market researchers at Fruit Tree have determined that Blast's success is due to a new rectangular juice boxes. Fruit Tree has decided to package its juice in rectangular boxes. Okay. All right. So Fruit Tree wants the new rectangular box to have the same volume as the current cylindrical can. Now it might be within a square centimeter um, or a cubic centimeter difference because there's going to be some decimal work here, and you can do a little bit of rounding. So first of all, you need to find the volume of this current cylinder, the current can. And so I kind of showed you right here what calculations you would need to do. This is review from yesterday. So you take the volume times the height times radius squared times pi. Whoops, I made an error here. This should not be that. That should be 3.14. Okay, so get the answer to that. That will then help you with the rectangle that you're going to create. Okay, so Fruit Tree Juice wants the new rectangular box to have the same volume as the current cylindrical can. So I talked about that. Part A says on centimeter grid paper, which I'll have on Seesaw, make a net for a box. This is a rectangular box that will hold the same amount of juice as a cylindrical can, again within a centimeter cubed. Now, since you probably don't have centimeter grid paper at home, I'm going to leave this next part optional, be optional. Cut out your net. When you're finished, fold and tape your pattern to form a rectangular box. So cutting, taping, any decorating of the juice box would be optional. You could do it if you wanted, if you had paper you wanted to cut, if you wanted to measure the paper, all of that stuff. Here's what you need to do though. You need to give the dimensions of your juice box. Are there other possibilities for the dimensions? Explain. So, yes, you could do this one way to get an area of about, or a volume of about something centimeters cubed. Or you could do this another way. So I want you to try to challenge yourself. Maybe you could figure out two ways to make this box. Okay. Compare your juice box with the boxes made by your classmates. Obviously, we're not together. So I might post some pictures on this, and so we can do this together next week. So don't worry about that. Then part B. I want you to compare the surface area of the cylindrical can with the surface area of your juice box. So you have done surface area of rectangular prisms before. So you're going to need to do that. You're going to need to get your surface area. Surface area with cylinders is a little tricky. We've talked about that a little bit. But if we think about this, circumference times the height will give the area of the rectangle. Remember from last week, we have the rectangle, and then we have the two cylinder or circular bases and the tops and the bottom. So this part right here, remember, is the circumference. If we multiply that by the height, we'll get the area. Now, Here I gave you kind of the formula in words and in numbers, and I gave you the kind of the calculations for today. Surface area of the can or cylinder is the area of the rectangular side. So that would be 2 times radius times pi times height, because circumference is um, 2 pi r, or pi times diameter, which is double the radius. Okay. Going back to the formula, plus 2 times radius squared times pi. Well, radius squared times pi is area, and we have it doubled, so that's why it's times 2. So in this case, it would be 2 times 2.7, which is the radius, times pi, times 11, which is the height, plus 2 times 2.7 squared. Remember, that's 2.7 times 2.7 times pi, 3.14. That'll give you the surface area of your can. And then compare that to the surface area of your rectangular box. If a cylinder and a rectangular box have the same volume, will the box always have a greater surface area? Explain. So once you know your answer to number 1, you can explain that for number 2. So think through that situation about what would happen. All right, there's a lot of information right there. Good luck with the problem. I know I wrote up a lot here, and I will share this information with you on Seesaw.